we have the case where root equals null. But what if root does not equal null? Well, we're going to write an insert function down here that's going to work recursively. We're going to call it void insert. I'm not going to do all of it for you, but we'll get you started. And we're going to have it pass in a data. I was going to say student, but it's generic, right? It will eventually be a student, but it won't be right now. Okay, so now we have data being passed in. Okay, so how's this going to work? Well, let's say root is not null. What we're going to do is we're going to say, well, let's insert it at the let's insert it at the root. So we'll go insert to insert, and it's the end of that chapter. All right, and so this we'll have to figure out where it gets inserted to. So root's not null. It points to an actual reference. So there's a node down there. So let that node figure it out. We start our recursion. Okay. There's the base case, right? And the base case is the, so we have to check if t's key is less than our current key, right? So data's key, I'm sorry. Data's key is less than our current key, right? So if 3 is less than 5, okay, and what? So if 3 is less than 5, so if we're in this situation, right, and this is, so if we have B being inserted at 3 and 3 is less than 5 and this is null, well, we need to attach B to there. So we wrap B into a node and attach it. So, and left shark, the left child is currently null. Wrap data into a node and make left equal to that and then return. Okay? And similarly, if it was greater than, if it was not B, but like something 700 number that was 95, okay, well then, and this was null, we would attach it over here, okay, as the right child. So if data's key is greater than current key, and we're going to assume keys are 700 numbers, they're unique, okay? Greater than the current key, right, and the right child is currently null, and then, you know, kind of, you know what to do. Okay, I think that's pretty obvious. All right, it's kind of, so we've gotten the base cases out of the way right now. Okay, and that's important because we have dealt with the base cases in a way that we look at them and try to see if we're hitting a base case before we call the recursion, right? That was that question above, where if we decide to recurse, if we decide to insert, right? So if we decide to go like left dot insert data up here, okay, well then it's gonna insert to the left, we're gonna get an infinite loop. I mean, eventually left's gonna equal null and this thing's gonna scream at us, right? But we're recursing before we get to the base case. So we're gonna get into trouble one way or another. Okay, we don't want to have infinite recursion, and we definitely don't want to be calling member functions on null references, right? That's not cool.